Okay, so this is lesson 5.8 for Algebra 1. Last lesson, guys, we looked at the slope-intercept form of an equation, and today we're going to talk about the point-slope form of an equation. I know they sound very similar, but they actually are different. But let's start by doing our review, or our warm-up first. If you have not done your warm-up, please pause the video and go ahead and try this. I don't want you to just sit there and watch me do it and not actually learn from it. So again, pause it and do it before you watch me do it. Okay, so to find the slope of a line, again, we need to remember that our slope formula is equal to y2 minus y1 over x2 minus x1. So if you want to label this your x1, this your y1, this your x2, this your y2, you can do that. So we're going to plug that in. 4 minus 2 over 3 minus 0. That comes out to 2 over 3. Okay, that one's pretty simple. So our next one, we're going to plug these in. 2 minus 8, so I'm doing my y2 minus my y1, over 4 minus a minus 2, okay? Make sure you've got that double right there. 2 minus 8 will come out to negative 6. 4 minus a minus 2 is actually 4 plus 2, which comes out to 6. So negative 6 over positive 6 is just a negative 1. Okay, and our last one, we're going to do negative 15 minus 3 over 12 minus 3. That comes out to negative 18 over 9. Negative 18 divided by 9 is equal to a negative 2. Okay, second part of the warm-up, write the following in slope-intercept form. So remember, slope-intercept form is y equals mx plus b, where m is our slope and b is our y-intercept. Okay, so it just wants us to get it in that form. That means we're solving for y, or we're isolating y. So first I'm going to start by distributing this 3. And then I'm going to move this 5 over because I want y by itself. So then I'm going to get y equals 3x. 6 plus 5 is 11. So we've got y is equal to 3x plus 11. Okay, again, you can only combine like terms. That's why you're adding the 5 and the 6 together. All right, on this next one, I'm going to move this 3x and this 20 over to the right side. If I move them over to the right side, they're going to have the opposite sign. So that's going to be 3x minus 20 because I'm subtracting them from both sides. Then I'm going to divide everything by 4 so that I can isolate y. And then I get y is equal to negative 3/4 x minus 20 divided by 4 is 5. Okay, so today we're going to look at graphing a line and writing a linear equation using something called the point-slope form. And then also finally we're going to look at writing a linear equation if we're just given 2 points on a line. So here's the deal with the point-slope form. If you know the slope and any point on a line, you can write an equation of the line by using the slope formula. For example, if you have a line that has a slope of 3 and it has the point 2, 1, we're going to let x and y be the other point on the line. We don't know what that is. We're just using a generic form, x, y. So we know that the slope formula, m, is equal to y2 minus y1 over x2 minus x1. We can set that equal to our slope, which in this case, they told us was 3. So 3 is equal to y minus 1. We're going to plug in our x, or our y1, over x minus 2. We're going to plug in our x2, or x1. Okay, next, I want to get rid of my denominator, so I want to get rid of this x minus 2. So in order to do that, I'm going to multiply both sides by x minus 2, because that will cancel this right here. So then I'm left with 3 times x minus 2 equals y minus a 1, okay? And then finally, I'm going to distribute this 3 to all these parts. And when I do that, I'm going to actually get on this side 3x minus 6 and y minus 1. And I could rearrange this and I would end up eventually with the slope intercept form of an equation. But today we're going to look at something else. It's called the point slope form. And actually right here, if we stopped right here, this would be the point slope form of an equation. So here's the deal with the point slope form of a line. The line with a slope m will contain a point x1, y1, and we can describe it by this other form of equation, okay, the point slope form. And that says y minus y1 is equal to x minus x1. And this is a really helpful equation, you guys, especially if you know a slope and then a point on the line, because sometimes we don't always know the y-intercept and we can't just plug that into the slope-intercept form of an equation. That's that y equals mx plus b. And the only time you can use this is if you know the actual y-intercept. And this other form that we're going to talk about today is more helpful if you don't know the y-intercept, but you know another point on the line. Okay, so here's how it works. They want us to write an equation in point slope form for the line with the given slope that contains the given point. So we're given the slope 1/6 and we're given the point 5, 1. So the point slope form, it's already written for us. Y minus y1 is equal to m times x minus x1. And we're just going to plug things in. So my y1 is right here, 1. My m is 1/6. And then my x1 is just 5. So we could stop there. That would be the point slope form. But I want to see if I can get you guys to go to the slope-intercept form. So now I'm going to distribute this 1/6 throughout. And then I'm going to add 1 to both sides. And y is equal to 1/6 x. Now if I add 1, that's like adding 6 over 6. So that comes out to minus 5/6 plus 6 over 6. That's going to come out to 1/6. So I got all the way to the slope-intercept form of an equation just by having that point slope form. Okay, next example. Write an equation in point slope form for the line with the given slope that contains the point. So I'm just going to plug in my y1, plug in my slope, and then plug in my x1. If I distribute now, this becomes minus 4x. When I distribute the negative 4, I'm going to have negative 4 times 0. Anything times 0 we know just goes away, so that's gone. And now I'm going to move this 3 over to the other side, and I get y equals negative 4x plus 3. So I went all the way from right here, the point slope form of an equation, to the slope-intercept form of the equation. Okay, again, we're going to write this point slope form of the line. We're given a slope and we're given a point on the line. Again, reminder guys, this point isn't necessarily your y-intercept. That's why we can't just plug it into y equals mx plus b. We've got to use this point slope form. So I'm going to plug in my minus 4, and you have to keep that other minus sign because that's the way the equation is written. So I'm going to have a double minus on two sides. That actually becomes y plus 4 because I've got a negative by a negative. And then this is going to become x plus 1. If I stopped here, this would be far enough to be the point slope form of an equation, but I want to show you guys how to take it further. I'm going to distribute, so that means I'm going to get x plus 1. I'm going to move this 4 over. So y is equal to x minus 3, and we got all the way to the slope-intercept form of an equation. So in lesson 5.7, you guys graphed a line if you were given the equation in slope-intercept form, and you could also graph a line when you're given an equation in point-slope form. You're going to start by using the equation to identify the point that's on the line, and then you can get the slope from the equation to count over for your next point. So let's look at an example. So they want us to graph the line described by the equation given in point-slope form. Y minus 1 equals 2 times x minus 3. Well, point-slope form says that this value right here, sorry, I colored over it, that is your y1 value. This right here is your x1 value. So we know that the point 3, 1 is on the line. Then we know our slope out in front over here is 2, or we can look at it as 2 over 1. So our point on our line is 3, 1. So step 1 is to find that. I'm going to go over 3 and up 1. Step 2 is to count up 2 units because my slope is my rise over my run. So I'm going to count up 2, 1, 2, and then 1 unit over to the right. Put my second point there, connect the lines, and you just graphed that equation. Let's try another one. So we're given this equation in point slope form, y minus 4 equals 3/4 times x plus 2. Well, this one's a little tricky. We've got to really think about this. The y value is simple because it's just that 4. But technically, point slope form says it's the x minus the x1 value. So we have to rewrite this as x minus a minus 2 because that's the only way we were able to get to a plus 2. So your point on the line is actually -2, 4. Your slope is given as 3/4. So step 1 is to plot that point that's on the line. So we're going to go over -2 and up 4. And step 2 now is to count 3 units up and 4 units to the right because it's our rise over our run. So 1, 2, 3, 1, 2, 3, 4. I put a point at that new spot and I connect my lines and you have just graphed that line. Okay, let's try a third one. Graph the line described by the equation. Okay, so again, it says y plus 3 here. The original point slope form is actually y minus y1 times equals m times x minus x1. So we know that we need an actual negative out here, so it's going to be y minus a minus 3 is equal to 0, your slope, times x minus 4. So your point is 4, -3, and your slope is 0. So we're going to plot the point 4, -3. We're going to count over 4, 1, 2, 3, 4, and down -3 to get our point. Then the slope is 0, so that means that every value of x will be exactly at y equals -3. Since it's a 0 slope, that is a horizontal line, so it's just going to run across right there at y equals -3, and you are done with that line. Okay, we can also write the equation that describes the line in slope-intercept form. So if we're given the slope of 3 and then this point -1, 4 on the line, this is kind of what we've already been doing. We would write the equation first in point slope form. So y minus y1 is y minus 4 equals m, our 3, times x minus a minus 1. That becomes y minus 4 equals 3 times x plus 1. So again, this is your point slope form. And then I kind of was already doing this in the beginning examples. When we want to get to now our slope intercept form, we're just going to solve for y. So I'm going to rewrite this equation just so it's down here for you guys. I need to distribute this 3 first, so that's 3x plus 3. And then I'm going to move this 4 over, so I get y is equal to 3x plus 7. And you just got now to the slope-intercept form. So there are 2 different ways of writing an equation. Okay, so another example, you could be given 2 points on the line, and you need to get it in point slope form, but first you need to know the slope of the line. We know that we can solve for the slope of the line, which is kind of what we did in the beginning in our warm-up. So that is equal to 1 minus a minus 3 over 4 minus 2. That is equal to 1 plus 3 over 4 minus 2, which is 4 over 2. So your slope is now 2. Now we're going to substitute that into our point slope form. You can pick either point here to plug in. I usually just pick my positive numbers to plug in. So I'm going to plug in the 0.4, 1. So that means I'm going to do y minus 1 is equal to 2 times x minus 4. And this would be the point slope form, and you'd be done if I had just said leave it in point slope form. Okay, finally, we're going to write the equation that describes the line in slope-intercept form. Okay, so this is, remember, slope-intercept form is our y equals mx plus b form of the equation. Okay, step one, we need to use the intercept to find 2 points, okay? Because we don't really know our slope yet, so we have to calculate slope from 2 points. Well, you know that your intercept, your x-intercept, at your x-intercept, your y value is 0, and at your y-intercept, your x value is 0. So we're given these 2 values already. We can find the actual points. Now we're going to plug those into our slope formula. So I'm going to use 1 minus 0 over 0 minus 1/4. That comes out to 1 over a negative 1/4. Now to get rid of dividing by a fraction, remember we just multiply by the reciprocal. So I'm going to multiply by a negative 4 over 1. That's how the bottom goes away. And I'm left with negative 4 over 1, which is just a negative 4. Now, I can plug that in to my y equals mx plus b equation because we already solved for our slope, negative 4. And we know our b value because they gave it to you in the beginning, plus 1. So that is the slope-intercept form. So big things from this lesson, guys. Slope-intercept form. Sorry, my phone keeps going off. Intercept form is when you have y equals mx plus b. Point slope form is that y minus y1 equals m times x minus x1. So big things for slope-intercept form, you have to know the y-intercept in order to use that. For point slope form, it's really nice because all you have to know is a point on the line. You don't have to actually know the y-intercept. So I think this will make more sense when you guys are doing your homework. And that is all.